All right, welcome to Computer Science 305, Programming Languages, and it's continuation of Ruby 2, and this time we're going to be looking at deeper understanding of expressions. So let's start that out, and we'll call this expression 01, or B, and so So inside of expressions, inside Ruby, we can actually do lots of different things. So we have our typical, so one of the things we normally do is assignment to a variable, right? But there's a way to do what we call parallel assignment in Ruby, which is what we might call an advanced technique. So think about this like, so normally we would say, for example, x equals 0, right? Well, interesting enough, we can do what's called parallel assignment by saying, A, B, C, right, equals x plus equals 1, and x plus equals 1. Right, and then if we go ahead and print these, so puts now we would think that A would be equal to x, B would be equal to x plus equals 1, and so that would be A would be 0, B would be 1, and C would be 2, right? But in reality, what we'll probably see is that A is equal to 0, B is equal to 1, and C is equal to 1. So we go ahead and run this. Oh, I need to save again. And we actually get x is equal to 2 for C, right? So, but we did the assignment in parallel, so that was the most important part, and it makes sense for why it's working. We've already talked about we can use. So we kind of went into partial detail on if and unless expressions. So the typical if would be like, for example, if x is equal to 4, then we said puts this appears to be true, and then we do an end, right? So if a condition, the code we're going to execute, that condition is true, and then end. We can also use unless. So unless the condition is true, so if the condition is false, then we do something. So for example, puts this appears to be false. And then for either if or unless, we can also use else. And we say puts this appears to be true. And we end, right? And we can also, for all of these, for both, for if, we can also use else if. So so for example, we could say, if else if it's equal to 5, then we put right, and so we can do that. Pretty simple to understand. We can, if we run all this, we should see, since x is equal to 0, we'll see it appears to, nothing will happen for this one, but then we will see false, right? So if we run this, this appears to be false. We can also do similar things where we can say x equals 4, and we can use what's called the we'll call these the if and unless expression modifiers. So what this is saying is we have something we want to do. We say this appears to be false. So then we call unless x is equal to 4, right? So we provide a condition on the statement, right? So unless is when the condition that we have is false, then we'll execute the statement. Otherwise we won't. And then we can also say this appears to be true. If we do this, right, we say if x is equal to 4. And this is saying when the condition we have is true, then we execute the statement. So if we run this, I have to actually save, and then we run it. We see now that it says this appears to be true, which is executing this line, as expected. So I alluded to case expressions earlier. So case expressions are a pretty simple concept. It's just basically a switch, but we can use it in all sorts of different ways. So for example, if we say we have a variable year equals 2018, and we say leap equals case, and we don't need an object here. So when our condition would be when year mod 400 is equal to 0, then true. When year mod 100 is equal to 0, then true. So when we do this, normally if we have a new line, we don't have to use a colon operator. But if it's if we're doing everything all on the same line, you need to follow it with a colon. Then we have the else. Year mod 4 is equal to 0, right? Then it's also true. Actually, we'll just leave that alone, and we just say end, right? So if we say puts leap, let's see what happens. Give me a failing, right? Hello. Oh, this should be false. And I'm still getting this weird error. Maybe let's just do that. Let's see what happens. Oh, hello, semicolon. What am I doing? Alright, let's try that. Alright, so we get false, right? Which makes sense. So the whole concept here is that we need to ensure that our content works correctly. So that was my bad. It's semicolon. If you have two statements on one line, you have to separate them because Ruby cannot figure that out. So now that we've gone through that, we'll do one more case statement just to clarify. So let's say we have an array music info equals so title equals title test. Make it so it's a little clearer to see. Artist equals artist test. You can see I'm really great with names here. Track equals track test. So if we were to do this, and what we can do is we can construct a case, right? So music info dot each, and we're going to say for each line, so for each item inside of music info, we can say case line. Now line is the thing that we're comparing against, right? It's just like in a switch statement in Java, switch on, for example, I, when each of our cases is one of the values that I can take in, can be here we can do a lot more than just look at any one individual value. What we can use is we can use actual expressions. So we say when, and then we can use a regular expression, and we're looking for title is equal to, and then dot star. So if we see title equals and then any characters, what we'll do is we'll print out the title is pound, and then we go we have one group, right, because this goes back to regular expressions and group matching. So then we can say $1. Similarly, we can say when the line is matches artist equals, and then a dot star, we can do the same thing. We can say puts artist is, and then $1 again. We can continue this one more time for track. And I can spell track correctly. And so this would say puts track is and $1. So we don't. Then we can end this and I've already ended it, and then end again. All right. So we run that, and then it should print out each one of those correctly. Title is title test, track artist is artist test, and track is track test. So worked out as expected, and so so that's the basic gist of how we operate a case statement. You can do pretty much anything you want inside the when, as long as it's a valid Ruby expression. So now, interestingly enough, we can do all sorts of other types of loops, right? So this is so I'm going to leave this at the end, and then the next thing that oh no, that's my bad. I do want to catch one more thing. So let's create a new file, expression 02.rb, and so this one we're going to look into a little more in depth. So previously we covered loops. We looked at the while loop. So for example, while line equals gets. And then we can do something, right? Some sort of code in there. And we also looked at the until x is. So we execute until this becomes true, and then we stop. And then we can put in some sort of code. So while tells us while this is true, we will continue executing. Until tells us while this is false, we continue executing. Those are some basic, easy to understand looping constructs. Ruby has a few other interesting ways of doing things. We call those iterators. So iterators are more important and more Ruby-esque way of doing iteration. So for example, if we had a file, we'll create in a second here. So we say for each ordinal. And we're going to do, for each line in the file, right, we're going to do something. So we'll create the file. And so it looks something like this. We just have 5 items in here. First, second, third, 8th, and 9th. Alright. And so inside here, we want to look at we're going to run a regular expression matching on this. So we're going to say if, and now there's don't worry about too much about what this is doing. So the $. Is our current location. So we're asking if the current line matches. It begins with 8th, right? EIG. To the so we're constructing a range here, and so let's see what this does. So go ahead and run it. This is 2. And we have a for each problem. Oh, sorry. It's for each. And I keep running into all sorts of issues. Oh, hello. Let's try this way. You know, we're going to do it this way. Oh, hello, can't find the file because I spelled it incorrectly. So, that's my fault. Ordinal. There we go. Okay, let's try it again. Okay, so there it goes. So, and I also misspelled first. one more time. Okay, so we have it prints out everything right as expected. Went through a whole bunch of business which we don't really need to care about, but essentially it walked from the first one down to the last one inside there, and then printed it out. Works great. Okay, that's just an iterator. The more important thing was not the contents of what was going on, but more the fact that we could do a for each on IO or file, actually, as expected. Okay, so let's bypass all that, and we can also use, as we've seen before, we can say print hello, just like we could before. We can, with if and unless, we can also use a while modifier. So we can say false, right? That will print nothing because the while will be never manage to make it. But we can do a similar to a do while construct inside of Java. We can start with a begin statement, which we can, which is the start of a block, right? So we're creating a block inside of our code, and then we just say end, and then while false. All right. So what we're actually doing is we're creating this block statement here with the print goodbye, and then we're putting the while false on it. This is constructing a do while for us because it's going to execute the block, and then we'll check the while. So if we run this, we should see. I need to save. We should see goodbye, right? Whereas we do not see hello. Now I think if we were to put this in a block, should execute that. Oh, or it will fail. Yes, very good. All right, so disregard. There are ways to do blocks, but anyway, moving along. So there's other types of iterators. We can also do numbers have a base iterator built in, which is times, which takes in a block. So we can create a do block here, and we can say print, and this is ho, and then we say end, right? It's a little Santa Claus action, and we run that, and we get ho ho ho. If we were to then append to that up to from 0 up to let's say, I don't know, 3, right? We can say do x and then print x followed by a space, end, and then we see this, it should print 3 x's. Oh, sorry, it should print 0 through 3. And then we can also finish this up with 0.step 12 by 3, and then we can use the curly brace notation for the block, print x followed by a space, and that will, and then we can we'll put a new line just to get rid of that. So what we should see is 3 hoes, 0 through 3, and then 0 through 12, skipping 3 each time, and that's what we see. Okay. So there's one other typical one that's available on hashes and arrays. So I'm going to do one for both. So we have an array, right? So bear in mind that in a hash or an array, you can hold other hashes and arrays, right? So if we have an array, let's say 1, 1, 2, 3, 5, which is the Fibonacci sequence, we can say each, and then val, or val, and then print val, right? So it's taking in a block on the each, and it gives us only one value, whatever the value at that current index that we're at. So if we do this, I'll put a new line. We should see 1, 1, 2, 3, 5, as expected. Now, interesting enough, if we create a new hash, right? Let's say list and we create this hash, right? And then we say hash.each. And this, if we say we'll use the do form, it gives us two variables, right? So we have key and value. And then what we can do is we can say puts, and we'll say just a quick simple one, key and right. And so if we run this now, we should see name Isaac course CSCI 305. Right, so that's how we can walk through those. There's also all sorts of other methods that are attached to hashes, but that's a pretty simple way of doing things. Now, Ruby also has, they have a for loop. It's very similar to Python, and so we can say for I in, and we can give it an array or a range or whatever we kind of want. We can say fee fi fo fum. I'm sure we all remember that. Then we could just say print I, right, followed by an empty space. And then we can do a range for I in 1.3. And we say print I, and then we say end. And then we can also say for I in file.open ordinal dot find all line is equal to starting with a D or ending with a D, right? Then what that should give us is what, second and third. And then what we'll do is we'll print I.jump, okay, followed by a space. So this should return fee fi fo fum 1 2 3 and second and third, right? Second and third, and eighth is spelled. There we go. It should return all that information separated by spaces. So let's go ahead and then we'll put a new line afterwards. So fee fi fo fum 1 2 3 second third as expected. So these are different ways we can iterate with the for loop. Typically it's not considered to be the best way of doing things in Ruby, but it's available to you. Finally, we can do while, and we say line equals gets. And so this is, now we want to look in, so this was the for in, right? Construct, and then before we were looking at iterators, right? So these were our iterators, and then we had just more, I would say this is control. Well, we'll call that iterators too. Why not? So if we were to go through this, once we get past all this stuff, so one of the other things we can do is we can control the loop, right? With break, redo, next, and then there's retry, but we'll get to that one in a minute. So let's say we have a line. While we are taking input in from the console, we can say next, right? Next says we're going to skip. It's like continue in in Java, but it takes a condition. So next if, and then we can say if line it matches from the beginning a space followed by just any space followed by a hash, which is in Ruby a comment, right? So we're going to skip comments. Then we say break if line is equivalent to end, right? So if we put an end, right, which is well, we'll get to that, but and then we stop at the end, and then redo, right? So we'll retry the entire process of the loop if our line.gsub has a backtick followed by followed by any characters, followed by the backtick. So in this case, what we're going to do is we're going to call the eval, which will evaluate any Ruby statement. Sorry, so it'll eval the contents of this group. So if we put it in backticks. So we'll go ahead and try this. So we run it. So now it's waiting for us to give it something, right? So let's say 1 + 1, and then we say end, and it ends it, right? Now what we could do is we could actually we'll print that with P. Let's try it one more time, and we say 1 + 1. I did not do anything. Not what I wanted to do. Anyway, regardless. Let's not do this. This is getting us way off the mark. What matters is that it allowed us to do that eval and actually execute the code. The more important part was that if we were to, as we saw when we did run this, is that if we do, it will keep running the loop. If we set a comment, it's going to skip that and not do anything. If we say end, it will end the whole thing. So redo just allows us to execute and then start back at the top. Next allows us to skip the rest of the actual current loop, and then break allows us to obviously break, and we can put conditions on all these things.